Hey y'all, okay, today we are going to connect what we've been doing, which is factor things. We were factoring them into the smallest units we could get that multiply to make something. That's what factor means. And we set it equal to 0. We made tiny equations and found solutions. Okay, those solutions on the graph represent the x-intercepts. We call them zeros because we set it equal to 0. Then we're going to connect that to what happens if we don't set it equal to 0. What does that mean? Okay, so this is posted for you. You should print it if you don't already have a copy of it. And let's do this side and see what it means to find solutions in two different methods. Okay, so I want what we've been doing with factoring to make sense to you. So the directions say connecting algebraic methods to the graph. Use two colors for the best visual. Solve by factoring on this side. Then compare the graph solutions, the zeros or intersections. So these are going to be what's called zeros because we're going to set it equal to 0. These are going to be intersections. And we're going to see what happens when we look at those different kind of equations. Okay, so we have f of x equals x squared minus 9. We're going to set it equal to 0. We're going to factor this perfect square, difference of perfect squares. They're the conjugates. It's going to be x minus 3 and x plus 3. So now we're going to set two tiny equations, x minus 3 equals 0 and x plus 3 equals 0. When we solve each of those, we get 3 and negative 3. I also want to graph this one because I know the zeros are 3 and negative 3. They're going to be here at 3 and at negative 3. And this one is shifted down 9. So it goes right here. And so this is a sketch of f of x. So we've solved the left-hand side. Now I want to do this side. Solve by graphing x squared equals 9. Note that they are the similar, the same kind of equation. If I had moved this 9 to the other side, it would be positive just like this one. So these are very, very similar things, but this form is different. In order to factor it, we have to set it equal to 0. This one is not equal to 0. So what I want to do is I want to find out where x squared, the graph, runs into 9. Okay, so this is going to look like a parabola when I graph it, and this will be a straight line at y equals 9. So it'll be straight across the top here. So let's look at that on the calculator. I'm going to put in two equations just like I've written out here for you. So y1, let's put in x squared. So here's x, and then the squared buttons over here. Then I want to graph y equals 9. So I'm doing just like I've got typed out on this side here. All right, and I fixed the graph of my first parabola a little bit so that it wouldn't be in the way of this one. So now I'm going to hit the graph button and see what happens when I graph. I should have a blue line and a red line. And I do. I have a blue line and a red line. So this time when I'm solving, I'm not looking for where they cross the x-axis like I was here, negative 3 and positive 3. I'm looking for the red runs into the blue. And so let's do this. So we're going to do these buttons. So you need to try it on yours. Second, and then the trace button. And then we're going to find the intersection. We're going to find both intersections actually. So here we go. Second, trace, intersection is 5. And then it asks these questions. The first curve, is it blue? We say yes. Is the second curve red? Yes. Which intersection do you want to find? So you have to tell the calculator or it won't know which one to find. Let's try this one, enter. And the intersection occurs at negative 3. So down here, I've got x equals negative 3. And then let's find the other one. We're going to guess that since one of these was negative 3, maybe the other one's at positive 3, since these are essentially the same equation. So if I do second trace again, intersection, number 5, And then I'm still going to answer the questions blue and red. So blue, red, but this time I have to move the little cursor over to here and say I would like to find this one. And yes, the calculator found the other value is +3. So I'm going to graph this one in purple just so we can see what it looks like. So this one's going to be in purple. And it went, if I look at it on the calculator, I'm saying it starts at 0, but up here at 3 and at negative, oops, wrong value, at 9, I'm going to have an intersection. So this parabola goes through this point and this point because we're crossing not 0, but we're crossing the y equals 9 graph. So these are in two different positions, but the x value is -3 and +3, and -3 and +3. So there are two different ways to find the answer to the same kind of a question. You can either factor it and set it equal to 0, or you can graph it and find out where they cross. So they gave the same answers, they're just two different methods. So this is the intersection, and these are the zeros, and they came up with the same answer. Number 2, I would like for you to pause this video and factor this, and then see if you can find the zeros for right here to solve by factoring. Okay, so I've got some notes started. First of all, this is a minus sign, so these are going to be different signs. And then I multiplied 2 times 12. Remember how we called this AC? And we made a list. So if we make 24 into our list, I've got 2 and 12, 3 and 8, 4 and 6. And these two guys, 3 and 8, if I subtract them, I get 5. Now, we learned a quick method to do that the other day. Actually, it wasn't that quick, but it was a good method to use the grouping. But I do know that the only way to factor 2x squared is 2x and x. So in order for me to get 3 and 8, I know this is going to have to be 4 and this will have to be 3. How do I know that? Because I always multiply the outside. That makes 8x. And on the inside, that makes 3x. I do need to make it +8 minus 3 to get +5 here. So 2 times +4 gives me 8, and 2x minus 3 gives me the -3x. So now it's factored. Once I factor it, I need to set them both equal to 0. 2x equals 3, divide by 2. X equals 3/2. I'm just going to leave it like 3/2. And over here, x plus 4 equals 0. Subtract 4 from both sides. X equals -4. So that means that this parabola is going to go through -4, 1, 2, 3, 4, and 3/2, which is 1.5. So I'm going to graph that right there for now and show those as zeros. Okay, and I'll graph them on a calculator in just a sec. Let's graph over here. So I'm going to separate this equation into two pieces and just see what that looks like. And I'm going to have a little bit of an issue because this says 12 and my graph only goes up to 10, but I'll just squeeze that in there. We'll just add our two little lines and figure that out. So I'm going to type both of these into my calculator. So I've got 2x squared plus 5x equals 12. Notice that if I were to rewrite this equation, so if I say 0 equals 2x squared plus 5x minus 12, if I put the 12 on the other side, then this is one function that I'm graphing here, and then positive 12 is the other function. So that's what I'm doing, is just setting this equal to 0 like I would have on the other side, but then rearranging it so I have two pieces so they can intersect. So let's graph this now. I am going to have to change my window so that I can see the 12. So I'm going to move my window up a little bit. I'm going to make my y value bigger so that I can see up there. And there we go. So what I'm looking for now is this at -4 and this at 1.5. That's what I'm trying to see, is if they're the same. So intersect blue, red, and then guess. And right now it's going to guess this one that it's next to, and that's 1.5. That's the same as 3/2, so that's right. So here I am, but I'm at +12. So I'm up here at 10, 11, 12, 1.5. So I'm like right there. Squeeze that in there. And then the other value, let's make sure it is -4. Second, calculate intersection, blue, red, but hey, calculator, please figure out this one for me. And it's -4. So -4, 12, that's where this parabola goes. And it has a low at like -3. So I'm going to go, here's -3. Something like that. And then it crossed here at 12. So this is the purple one. And then if we threw in the other one into the graph, we could see it graph. It's 2x squared plus 5x plus 12, 2x squared plus 5x plus 12. Wait, it's -12. -12. There we go. So there's my intersection. And then here's 1.5, and here's -4. So it went all the way down past my line. I can't even see it. It went sort of like this, and then the V's down below it. But notice how these values are the same. The X value here is at 1.5, and this value is at 4. So they're the same values. -4 and 3/2. So what we're trying to do here is connecting the ideas of what it means to solve things. We're actually finding out where this graph crosses 0 here, the x-axis, or we could rearrange it and solve it and find out where they intersect. So that's what we're working on when we're finding solutions. We're finding out where things cross. So this is us crossing 0 for these guys versus crossing another point. So now what I want you to do is I want you to solve this third one by factoring. So factor it, set it equal to 0, and write your answers here. Then I want you to solve this one by graphing. I want you to write in 4 and x minus 3 squared and find the intersections. Don't forget that it's second trace and the number 5 was intersection. And you're going to find the two values where they cross. These are very similar equations, and so I want you to have an idea about them when we get to this part and we start to solve here. I want you to see that that still works. On the back side, on the second page, if you printed it on one page, it would be the back side. I have it on 2 pages. I've got more solved by factoring, but this time there's a twist. So in number 4, this equation, x squared minus x minus 6, you can factor. But over here, this is almost the same equation, but the signs are all wrong. So if you take out the negative first, you're going to factor out a -1. You can think of it as factoring out the negative or factoring out -1 and then factoring it. This parabola should go up, right? This is positive a. And this equation should go down because it's -a. Let's find out if they have the same solutions. And you can graph them on the calculator to see that happen. So I want to see 2 graphs here. I want to see the one for this one in some color. Tell me what color it is. Or call it F. Or you could call this one G. You can label it. I did that here on this very first equation. I labeled the blue F. I could have labeled this blue one G of X. And that would have I would have been able to tell them apart. And then here, these are very similar equations, but do they cross the same value? So this is a difference of squares. This is a difference of squares. I'll just remind you here that 1/2 times 1/2 equals 1/4. So this is the root, 1/2. And then what's the same about them and what is different? So why is that? And then this last one, we're going to solve this one by factoring. So this is a harder one with the value in the front. You might need to make that list. And over here, I want you to solve by graphing this parabola equal to this line and find out where they intersect. So here you're looking for intersection, and here you're looking for zeros. So they're going to be similar problems, but you're looking for different methods to find the solutions that work. And then poster solutions, we'll go over the whole thing tomorrow before we, and then we're going to see about any questions from Delta Math. And you can let me know, come to office hours and see if you have questions about this worksheet or about any of the Delta Math before your quiz. So there's a quiz on factoring that's coming up. Check Classroom for any details. All right, thanks guys.